Next unit, Unit 2 is all about graphs and what information we can get from them. So in this first lesson, we're just going to look at 5 different graphs that you guys are going to be asked to create, both with pencil and paper and on a computer or calculator as well, and then kind of what we can learn from each graph. Some of these graphs you have seen before, and some might be new to you. So the first one is a dot plot. We have done these in class, okay? You just put a dot for every group, every category, whatever it is that you're measuring. Every time it happens, you put a dot, okay? So some characteristics of dot plots. They show you individual values, okay? Each one of these is a rattlesnake. If I had qualitative data down there and I had, test scores, I could see how many 72s there were and how many 73s. It also shows you the shape of the distribution, so I can see kind of how the data are spread out. I can see that there's a lot of rattlesnakes and green cobras, and then these a little bit less. We can use a dot plot for quantitative or qualitative data, so it'll work for either one. This example here is qualitative data, but I could also put numbers down on the bottom like we did in class with your heights and make a dot plot with quantitative data. Okay, dot plots work best when we have a small number of data values and a small number of groups. So like this, there's maybe, I don't know, just looking and guessing 20 to 30 dots. That's a small number of data values. If you had a group of, let's say, all of Patriot, 2,700 students, I don't think you want to sit there and draw 2,700 little dots. So that data would be too large for a dot plot. Next graph is a stem and leaf plot, which you may have seen back in middle school. All right, characteristics of a stem and leaf plot. It shows individual values. Again, I can see 72, 72, 74. I can see each individual data point. But it also shows me the shape and the center. So I can see like this somewhere here would probably be the middle of all of these numbers. I can see they're spread out. There's more in the 70s and 80s, a little bit less in the 90s, and then very few 100s. Okay, stem and leaf plot obviously has to be quantitative data. We have to have numbers because I can't split words up into stems and leaves. Just important thing to note when you're making a stem and leaf plot. The leaves have to be single digits. So if you have 3-digit numbers like this where they have 100, you have to put 2 digits in the stem and 1 in the leaf because the leaf always has to be a single digit. Then we have something that you saw in Algebra 1, which is a box plot, or you probably called it a box and whisker. Okay, box and whisker shows you the 5-number summary, which is the minimum, the lowest number, the maximum, the highest number, the median, which is the middle number, and then Q1 and Q3, which is halfway between these two things. So this one is halfway between the min and the median, and Q3 is halfway between the median and the max. All right, what does a box plot show us? It shows us the center. I can see this line right here is the exact middle of my data, and it shows me how it's spread out. Are there more values above the middle, more values below the middle? How does it look? Is my box really tiny, so all my data are close together, or is my box really big, so all my data are spread out? Okay, what a box plot does not show you, like the last two that we looked at, is it does not show you individual data values. I know that there are some data values somewhere in here between 22 and 31, but I don't know exactly how many, and I don't know what they are. I know they're somewhere between 22 and 31, but I don't know, is it 23, is it 27? I can't see the individual data values in a box plot. All right, and again, this has to be quantitative data because we have to be able to find a median and all of that stuff. Okay, then we have a histogram, which I think you've seen in middle school too. Okay, histogram shows the distribution of the data, but not the individual data values. So again, I see that there are 3 numbers somewhere between 60 and 65, but I don't know what those individual numbers are. Okay. For a histogram, data is broken up into groups, which are called classes, and the graph shows the number of values in each class. So here, each class is 5 feet wide, and so from 60 to 65 feet, there are 3. From 65 to 70 feet, there are 3. From 70 to 75, now there are 8 trees. So it shows how many of my data points are in between these two values. Okay. Now, here's the key. A histogram has to be quantitative data. And you might be thinking, well, why, if I had something with colors, why couldn't I put blue, red, purple, and how many people picked each color? That would be a bar graph. It's not a histogram. Okay, there is a difference. Histogram has to be quantitative data because notice how these bars are all touching. It means they go together. All right. It's a continuum. There's no gap between the end of the first group and the beginning of the second one. And it has to do with finding the area of the boxes, which is something that we're not going to look at in this class. But that's the difference between a histogram and a bar graph. So a histogram has to be quantitative data, and you have to put the bars next to each other, touching each other. They cannot be separated. There can't be any gaps in between, like a bar graph, which we could use to show qualitative data. All right, then the last graph we're going to look at is called a cumulative frequency graph, or an ogive. Okay, ogive, not ogive, no, not ogive, ogive. The G sounds like a J. Okay. What a cumulative frequency graph, or an ogive, is, it shows the cumulative frequency at each class boundary. So you could take data and you could make a histogram with the data, and then you can also make an ogive with the data. And cumulative just means I keep counting. So from 10 to 11, this is somewhere less than 20 people. Then from 11 to 12, if I add in the people that are in this group, now the total, so from 10 to 12, is up to 40. All right, then when I add in the 13-year-olds, now I'm up to 60. Add in the 14-year-olds, now I'm up to like 65, and it keeps going. So it's the frequency of all the groups from the beginning up to wherever you are. All right. Again, because this is the same thing as a histogram, we have to use quantitative data. And an ogive is nice because you can easily find the number of data values that are at or below a certain number. So, for example, if I showed you this ogive and I said, how many of the people in this group are 16 years old or younger? You just go to 16, bam, it's right there at 120. So there are 120 people somewhere between 10 and 16 years old. All right. I will give you a sheet that shows you exactly how to make each of these graphs, and we will do lots of practice in class. So just make sure you have these characteristics down in your notes, and then we'll take care of the rest of it in class.